let's have a look at the contents we're going to cover in today's first lesson of our elementary programming course. So first, we're going to get to know each other. We're going to get to know programming a bit. And we're going to have a look at Scratch as a programming language. And finally, we're going to spend the most of this lesson building a simple Scratch program. And now let's get to know some of you. So for each of you, I'm going to ask your name, your grade that you're going into, and why you want to learn programming. Is there someone who wants to go first? Okay, then I'll call you on by the order I see you on my screen. So Camille, what grade are you going into, and why do you want to learn programming?
Okay, it's kind of noisy, but hi, I'm Camille. I'm going into grade 5, and I want to learn programming because it sounded interesting.
Yeah, that's a really good reason. And that was kind of why I wanted to learn programming in the first place too. Like you, I was going into grade 5 when I first approached programming. And although I didn't do it with Scratch at first, I did it with Java. I came to really like it. It was very interesting and very enjoyable. And now, Wen, are you there?
Yes.
Hello, what's your name?
Like my name is Wen, and yeah.
Yeah, which grade are you going into?
Grade 11.
Grade 11.
Yeah,
wow, that's older than me.
Really?
Are you new to programming, or have you been
I mean,
at it for some time?
never touched it before, so.
Yeah. Are you familiar with Scratch, the platform you will be using?
No.
Okay, then we're all going to learn together then. And finally, Emo Kid.
Okay, hi, my name's Henry. I'm going into grade 5, and the reason I want to learn programming is because I want to get good at it.
Yeah. Have you known how to program before, or are you completely new to it?
I've programmed before. I made lots of good Scratch games that were public, but yeah, those were my only success.
Yeah, that's great. So there's quite a large range of age levels and skill levels in this room, which is great. Let's move on. Any questions before we start? If not, let's first look at some of the things that one can program. So in today's world, electronics, which are objects that can be programmed, are all around us, from computers to children's toys, the phones, to cars and televisions. And although this range of things may appear very different and very diverse, they all have one thing in common, and that is someone has to sit down and write the code for it to work. And although in this course, we're only going to explore one area of programming, which is designing simple programs for a computerized code language, Scratch. It will open the doors to a lot of programming opportunities. And as I mentioned, the central idea of programming is coming up with an idea, breaking it down, and telling the computer to do it. And that's the job of the programmer. And the job of the computer is to carry out the instructions that the programmer gave it, which is called running the program. And since most computers and computer systems cannot understand what we call natural languages, which are the languages that we use to communicate to one another, like English, French, Mandarin, and so on. We can use what we call a programming language to communicate with computers. And so a programming language is basically the system with which you tell the computer what to do. And there is a whole range of programming languages, and most of which is text-based, which means you type your instructions into the computer, such as Java, Python, C, C++, and so on. But in this course, we're going to use what we call a graphical programming language. So instead of using text, the main method of telling the computer what to do is using blocks and graphics, which are shapes. And this is Scratch. So in Scratch, if you haven't met it before, you use blocks to form commands, which you tell the computer to execute. We can explore the Scratch interface a bit. So here's the Scratch website, scratch.mit.edu. We're currently on the Scratch homepage. We can click Create at the top left to create a blank project. And as soon as we do that, we have this interface that we can use to create, design, and run our program. So currently, our program is blank. There is the screen is divided into 3 main regions. On the left, there's the code section. So the very left part of the screen contains all the commands that we can choose from to make our character do specific things. For example, we can, in the motion tab, we can make the character move in various ways, rotate. In the looks tab, we can make it change costumes, change its size, and do many other things. In the sound tab, we can add sound effects for this character. In the events tab, these are what we call event blocks. They tell the character when to execute a specific instruction. We'll get all of these later. And we have a few other tabs that help us arrange our instructions in a way that the computer knows how and when to execute them. On the right, we have 2 panels. The window on the top right is what we call the stage. It's basically the output of the program. And in Scratch, the visual output of the program is composed of a background image and several characters. So in our default blank Scratch template, the one character that's included on the stage is the cat. But we can add lots more. And the bottom panel displays all the characters, or sprites as we call them, that we have in our program. We can choose them. We can choose a specific one of them to edit or to program. And on the very right, there's the stage, which is the background of the scene, which can also be programmed. And so once we have an idea of how Scratch works, we can see an example of what you can do with Scratch. And there are many examples. If we go on the Scratch website and click Explore, you can see all the pre-made projects that other people on Scratch have created, since Scratch is not only a programming language, but also a platform for sharing projects. So for example, if we go to the Animations tab, we can find all these animated scenes that can be made with the tools that we've just seen. There's a tab for art. Scratch can also be used to create interactive artwork because it has a visual canvas. And most importantly, there's the Games tab, which contains all the games that can be made using Scratch. And although the inputs are rather limited, you can make a really wide range of games with the tools provided. For example, we can look at this one, which represents kind of a typical game that you can make on Scratch. So there's a character, a sprite, which represents the player. There is a scene, a background in the stage, and there are other objects on the stage, such as a block of text and the ground object here. And the controls, which are how the player manipulates the character, are quite typical. You use the arrow keys on the keyboard to make the sprite move. So in a Scratch game, like many other games, the experience comes with varying levels of difficulty. It starts easy at the first and gets harder and harder. And there is a fixed objective, which in this case is to get the character to the right side of the screen. So if anyone actually wants to try this game by remote controlling my screen using the zoom controls, yeah, if not, sorry.
You can remotely control the game.
Yeah, in Zoom, there's a function which allows you to remote control the other user's screen. I believe there's a menu at the top of the screen that's either green or black. You click on the black section, and there should be a button called Request Remote Control.
That sounds so cool. Wait, let me try. I can't find the button, so
Okay, we can
I
move
can't
on.
find it either.
Okay. And I forgot to mention, at the top left corner of the screen, the green flag and the red stop sign buttons are also some of the main features of Scratch. So when you first load the page, the green flag button starts the program. And when the program is running, you can click the red stop button at any time to stop it. And now we're going to have a look at the first project that we'll be trying to create today on Scratch. So the final result looks like this. We have the sprite that we first met here. And we can see it walking right and left on the screen and quickly alternating directions when it hits the wall. And we can also look at the code that's required to make that animation. These blocks are actually not required. We only have to look at this part. So if we compare our finished product for today with our blank project, the one difference is this block of code right here. This is all we need to get the cat moving in the way we just saw. We don't have to do anything with the appearance of the sprite because it's already given to us. And so let's first explore the motion tab on the left. This whole area, by the way, is called the code palette. It's where you can find all the instructions to choose from. So if we want to make the sprite move a certain number of what we call steps in its current direction, the block we use is the very first one, move 10 steps. So in Scratch, the stage can be thought of as a coordinate system. So there are two axes which intersect at the center of the screen. And any point on the screen can be described by two numbers. The x value, how far it is along this line, and the y value, how far it is along this line. So if you look here, the cat is currently at x value 0 and y value 0. This is because it's positioned right at the center, where both x and y are 0. If we move the cat along the x-axis, for example, to here, you will see that the x value has changed by a lot. And if you drag the cat backward, you can see that the x value is now negative. And if we try moving the cat along the y-axis, when it's at the top of the screen, the y-axis, the y value is big. And when we're at the bottom of the screen, the y value is small. And we can actually select here and type the coordinates that we want the cat to be at, and it will go to that location. For example, if I type 0 and 0, it will be back at the center of the stage. And now we go back to our blocks. So these commands make the cat move a certain number of units in its current direction. For example, if we click on the move 10 steps block, it will actually cause this block to run. And if you're watching the stage, you'll notice that whenever I click here, the cat will move slightly to the right. And if you watch this text box, you'll notice that every time it clicks this, it changes by exactly 10 steps. We can also rotate the sprite by going to the direction text box. We'll see something like a clock, and we can make it turn in any direction along the clock. For example, if we want to make it go backwards, the direction will be negative 90 degrees. It will be facing left. And this time, if we click move 10 steps, it will move 10 steps to the left. And we can make it point up or down. Up will be 0 degrees, and down will be 180 degrees. In that case, clicking on this will make it move in the direction it's pointing in. Let's change this back to 90, which is right, and bring it back to 0, 0. So right now, we have been able to make it move whenever we click the block. But if we look at our demonstration project here, the cat moves by itself without the user having to click on these blocks. So the way we do it is using two blocks, one in the events tab and one in the control tab. In the events tab, we use the block when green flag clicked, which basically is a signal that whenever the user clicks the green flag button to start the game, we should run a certain block of code. And if we snap a block to here, this means that whenever the green flag is clicked, we want to run this section of code that's snapped right below the block. And so now whenever the user clicks the green flag, it moves. But do you see the difference? It only moves once, not continuously. In our project, we want the cat to move continuously without stopping until the user clicks the stop button. The way we do this is using a block in the control tab, the forever block. What this does is it repeats forever whatever is sandwiched in between these two parts of the block. We can put the move 10 steps block in here, sandwiched inside the forever loop, and snap the forever loop back onto the when green flag clicked block. And we have something like this, which tells the program that whenever the user clicks the green flag, the cat will repeat forever, move 10 steps. Not bad, good start. At this point, if you want to follow along and make this block of code on your devices, that would be great. Do all of you have Scratch accounts?
Sort of.
Yeah, if you don't, I'll show you how to make a new one. So just go to scratch.mit.edu. On the top right corner of the page, click Join Scratch. Write your username. Create a password. This doesn't really matter, but you can just select whatever. You can enter your birthday. And enter your email address, then click create your account. And once your account is made, you will see something similar to this page. And you can do what I just did, which is click create to make a blank project. Yeah. Are we all there?
Yep.
Yep, I
Okay.
just have a split screen.
Okay, good. And you can create this block of code on your end as well. I'll just reset the cat. Are you all done?
Almost. Okay.
Okay. And now we've just seen another problem. The cat goes to the right of the screen and it doesn't turn back. It gets stuck on the right wall of the stage. So if we look at the project that we want to make, we'll notice that it turns back whenever it hits a wall. And Scratch actually has a block that's designed just for that. There is a block in Scratch that will tell the cat to turn back if it hits a wall. And that is in the motion tab. The block is called if on edge bounds. If we click it and run the block, it will determine whether the cat is touching the edge of the screen. And if it is touching the edge of the screen, the cat will rotate 180 degrees so that it will continue in the opposite direction. If we click it once, you see it's moved. And if we drag it to another edge and click it again, it'll turn back in the other direction. And we can put this block in with the move 10 steps block inside the forever loop so that it always senses whether the cat is on the edge while it's moving, and it turns back automatically whenever that happens. So this is what we get. And now we notice another problem. If we look at our demo project, the cat doesn't turn upside down when it reaches the edge. It only flips back in the opposite direction. And if we look at the two positions, this position and this position, we'll see that there are that there are vertical mirror images of each other. And there's a place on Scratch to do that too. It's also in the motion tab, and the block is all the way at the bottom of the motion tab. It's called set rotation style. So this block determines whether the cat can rotate in any direction, or whether it can only flip from left to right, or if it doesn't rotate at all. So we want to set it here to left to right, so that it only flips in the vertical direction when it bounces from a wall, and it doesn't go upside down. If we just click it, that will fix the problem. But we're going to add it to our script anyways. You'll notice that this block only has to be run once to fix the problem. And this is why we don't include it in the forever loop. Instead, we do it just before we enter the forever loop, after the green flag is clicked. And so here's our program. And now our little program is looking more and more like what we have here in the demonstration. Except the cat in the demo has actually two positions, two images, or two what we call costumes in Scratch. And you'll notice that as it's walking, it's switching rapidly between those two costumes. And that makes it look like the cat is really walking instead of just sliding around. And those two costumes for the cat are actually built into Scratch. So here on the left side of the screen, you can see 3 tabs: code, costumes, and sounds. We're now going to the costumes tab. And as you can see here, there are 2 pre-built images for the cat. And we can switch between these 2 images by clicking on them in the costumes tab. But we can also do that through the code. If we go to the code tab and click on the looks tab in the palette, you will see 2 related blocks: switch costume to something and next costume. Here, because we wanted to alternate rapidly between the 2 costumes, we use next costume. If we just click on it, you will see it switches the look of the cat. And if we click it again, it switches back. And we wanted to keep doing that as it walks. So we put that into the forever loop along with the motion blocks. And if we test it now, that looks a bit fast. We have to find a way to slow this motion down so that it actually looks like it's walking properly. And we do that with the Scratch wait block, which is the controls tab. There's a block that says wait 1 second. We can drag it into the stage area, the code area. And if we click it, it doesn't do anything. However, if we have, say, a block underneath it, clicking on this will make it wait the number of seconds that we put here, and then move on to the rest of the code. For example, if we click this, it moves 10 steps after 1 second. And if we put it inside the forever loop, after the loop reaches this block, it will wait 1 second before going on to another iteration of the loop. And 1 second is a bit long of a wait for this. So we can change it to something like 0.2 seconds. And you can see it's slowed down by a lot. A bit too slow. 0.1 seconds might be better. Yeah, that's better. And finally, you can see that when we click the green start button, the cat starts walking at whatever position it left off the last time we ran the program. But here, when we click the green start button, the cat always starts off from the center and goes right. And we can do that with a couple more blocks in the motion tab. The go to block and the point in direction block. The go to block makes the scratch go to a particular place in the coordinate system, which I've described earlier. For example, if we put x equals, say, 50 and y equals, say, -50, and we click the block, the cat will go there. And if we say point in direction -90, and we click it, the cat will point left. So when the game starts, when the animation starts, we want the cat to be pointing right in the direction 90 and at the center. So x equals 0 and y equals 0. So we change the blocks like this. We snap them together and we snap them under the when green flag clicked block so that this happens whenever the animation is started. And now that looks exactly like our demo project. Since we still have a bit of time, we can explore some of the other blocks in the motion tab. In addition to these basic blocks, Scratch has many other ways of moving our sprites. We can make it turn a certain number of degrees instead of pointing in a fixed direction. For example, we can do this. And this, as you see, will make the sprite go in a circle, because whenever it runs the loop, it turns 15 degrees to the right. And since the rotation style is left to right, as it says here, the cat won't actually rotate all the way. But when we use the move 10 steps block, the direction here is not necessarily the direction the cat is pointing in. It's whatever a direction that we made the cat go in based on this block. However, if we change the rotation style to all around, we'll see that the turn 15 degrees block also makes the cat actually rotate. And if you ever want to remove a certain block from a stack of code, you first have to drag the block that's under it to the side, then drag this to the palette. That will make it disappear. Then drag the rest of the blocks back where they were. And here's our program. So in addition to the go to block, we also have the glide to block, which makes the cat move smoothly to a certain position instead of making it go there instantly. For example, we use the glide 1 second to X 120Y0 block, and we modify the numbers. And if we click on it, it will move smoothly to the location that we described. And we can change these numbers to 0 and put them instead of the go-to block at the start of the step when the green flag is clicked. And it will glide to the origin whenever whenever the green flag is clicked. And in addition to all of these, we can also make the cat move in such a way that it interacts with the user. There are a few ways we can do this, and the most simple way is to use the mouse pointer. So when the user puts their mouse over the stage, the program can be sensitive to that. And for example, we can make the cat point towards the user's mouse pointer. There's a block reserved for that. It's called point towards mouse pointer. And we can set the rotation style to all around. Change it here as well. And you can see that whenever we click this block, it will point in the direction that we clicked it in. And if we put it in the actual program, it will always move towards the mouse pointer. And there's the a go to random position block and the go to mouse pointer block. They're what they do is fairly obvious. And then the cool thing about Scratch is we don't have to be limited to this one sprite. We can add many more characters with various visual appearances that Scratch has ready for us. To do this, we use the cat head button at the bottom right corner of the screen. It's labeled choose a sprite. And we get this library of sprites to choose from. Some of these sprites have multiple costumes, as we've just seen for the cat. And if we hover our mouse above them, it will scroll through all the costumes that are available for that sprite. And so you'll see that many of the people and animal sprites have several different postures, and that many of the object sprites have different versions, like colors and so on. We can click on any of these to add it to our program. I'll just click here on ball. And as with the cat, you can see all its costumes here. This one has 5. And the cool thing is you can make these characters interact with each other. For example, we can make the cat always point towards the ball. After we've added the ball, if we click here again, you'll see that the option for ball has automatically appeared. And we can make the cat move towards it. And if we make the ball move too, for example, and we can just make this up on the spot. When green flag is clicked, we repeat forever, move 10 steps, and if on edge, bounce. And turn 15 degrees clockwise as well. And now you see, after we've written this code to make the ball move continuously, the cat moves with it too, because it's always pointing towards the ball. If we make this smaller, say turn 2 degrees, the pattern becomes really interesting. Every time the ball moves, the cat senses it, and it takes steps towards the ball, but it will never reach it. And finally, there are the change x by, change y by, set x2 and set y2 blocks, which change the x and y coordinates independently without having to change them altogether, like with this block. So we can make the cat move horizontally, regardless of which direction it's currently pointing at, or vertically. Or we can set the x and y values to specific numbers without having to change them altogether. So let's summarize all the blocks that we've learned throughout this lesson. So we've met 3 main types of blocks. There's the kind of block with the rounded top and the notch on the bottom. The rounded top basically means it's going to start a block of code. It's going to start like a stack of code. And the code it will start should be snapped below it. And it's the control tab. There are all these blocks with various shapes. And the shapes correspond to the kind of roles that these blocks play. They regulate how other blocks are run. For example, the forever loop repeats in order all the blocks that we put in between them. This will repeat these in order, which means this gets run first, then this, and it goes back to the first. and repeats all over, and so on. And if there's a wait block in there, it will force the code to wait before going on to the next round of repeating. And if we want a block of code to run automatically, we snap these together. So we get a stack of code that runs whenever the green flag is clicked. And as you've just seen, we could have multiple stacks of code in the same sprite, and these will both make the sprite do things at the same time, but they might interfere with each other, as we see here. So when we design programs in Scratch, the best idea is to make different blocks of code serve different purposes. For example, we can make one block of code make the sprite move, and say another block of code make it play sounds, for example. There are some built-in sounds for each character in Scratch. And many of the sprites in this library have sounds that come with them. For example, the cat has the meow audio, and the ball has two types of audio, boing and pop. Pop is actually the default sound that comes with every sprite that you add to the program. But other sounds can be added as well. And sounds can be played by going directly to the Sounds tab and playing them. Or they can be controlled with the code. And these are all found in the Sounds tab in the palette. There are a few ways you can play them. There's the start sound block, which if you put it like in a block of code, for example, it will start the sound, then immediately move on to the next block. And if we have many more blocks in here, the sound will keep playing as the character executes these following blocks until the sound finishes. There is also the play sound until done block, which will start a sound, then wait until it's done before it goes on to the rest of the blocks in the stack. And there are several more blocks that concern effects, volume, and so on. We're going to get to them later in the next few weeks. But for now, that's pretty much all. I can show you the project that we're trying to create next lesson. And that will be all. So this is a demonstration of the project that we'll be trying to create next week. This player character interacts with the user using the arrow keys, the up and down arrow keys to move. And whenever the user presses the space bar, it launches a bow. It launches a ball that travels across the screen. So this builds on some of the topics we've learned in this project, like motion and making sprites sense each other. And it introduces a couple of more concepts. And that's all for this lesson.